Good afternoon to everybody. So our next aim in this course is to learn the concept of statistical learning. So this will take, I'll try to cover the whole concept in this week only because it is a vast topic actually. So minimum 4 hours is required to cover whole the concept. But anyway, we'll go a little bit slowly because it is a little bit mathematically rigor, and then a lot of things are to be understood properly. So that is why we should not be so much hurry to end it up in 4 hours or so, but I will try. Now in this topic, we shall first learn about the basic concept of statistical learning. Now you know possibly machine learning, deep learning, there are many such learning like reinforcement learning and then transfer learning, so many concepts. Nowadays it is very popular that learning concept is huge and it is applicable in many application scenarios. So statistical learning in the, with the current concept of learning scenarios, it is a very old concept, but it is still useful and popular to solve many data analytics activities. So the statistical learning also alternatively in many books called the statistical inference, and also it is called the hypothesis testing. So there are few basic steps involved so far the statistical learning is concerned. So we shall cover it, and then we will discuss a few case studies to understand the concept more comfortably. So 3 case studies will be discussed, and finally I'll discuss about the basic points or important points about the statistical learning. So this is the plan for in this topic. So let's first about starting with the introduction to the concept of statistical learning. Before going to start it, I just want to have a quick recapitulation of all the statistical methods that we have learned, because the concept of statistical methods, which we have covered in the last few classes, is heavily applicable in the concept of statistical learning. So we'll quickly go through about it. Now, so far this concept of statistical learning is concerned, it has high resemblance with this scene, and possibly you are able to guess exactly this picture shows a courtroom scene, right? And so this picture, as you see, there are few entities involved. One entity is the victim, right? And or you can say it is actually the accused, right? Accused or some accused against some what is called the crime, like. And then another entity, it is defense counsel who will advocate for the accused person. And then another is the opposition counsel, it is actually called the pleader, so who will plead the guilty of the accused person. And then finally judge is there, so judge has to take the accounts from the defense counsel as well as the pleader, and then to pronounce the final judgment about whether the accused person is really guilty or is not guilty. So this is the concept. Now this concept actually is very much similar to the concept of statistical learning, in fact. So that is why I want to share this screen, and then we will see exactly how this is relevant. But we will be able to understand this, that how this scene will be very much related to the concept of statistical learning shortly. Now, so far the concept of the statistical learning is concerned, as you know, we have discussed already. Statistics means what? Statistics means means measurement of central tendency or central location, right, or dispersion. All those things are there. So these are called statistics, like mean, median, mode, variance, standard deviation. All those things are there. And all those things are related to 2 ways. One is related to population. If the statistics related to population, then it is called the population statistics. On the other hand, we also know that a sample is a subset of a population which is usually chosen at random from the population data, and it is okay. So if the statistics related to sample, then it is called the sample statistics. Now the idea is that population is usually very large, and it is very difficult and not so much cost effective to have the population statistics precisely. So what is the idea is that if we have a sample, and from the sample statistics, can we infer something about the population statistics? If we do that, then we will be able to really solve many tedious problem, right? Time consuming problem, and then expensive problem very easily. So this concept actually is solved using the concept of statistical inference or learning. So basic idea of the statistical learning is to learn the population parameters like say mean, variance, etc. from the sample of the population. So it is the concept, and let's see how we can do that. Now, so as you know, so this concept of statistical learning related to it is the population. As you know, population is very vast, very large, and sometimes it is also okay if it is not so infinite, but very is very large actually to process it using even the high-speed computer also. So population, it is like this. And the distribution of population data, as you know, say for example, we are interested about the age of the person involved in the population. So age is your data. Now, if you plot the data obtained from the different people in your population, and then you will see a graph. And this graph actually, it is called the distribution curve. And it can be discrete or it can be continuous depending on the data that involved. And as you know, and it is very interesting that I have also explained that population data usually distributed following the normal distribution. As you know, the normal distribution is symmetric with respect to a peak. The peak is at the mean, and then different distribution characteristics are involved, like mean, variance, which actually decides what should be the shape and size of the curve. So there is a popular distribution curve usually matches with many applications, and it is the Gaussian curve. So it follows the Gaussian equation, and the Gaussian equation, as you see in this slide, it is shown as the function fx. And this function fx has two parameters, mu and sigma. And you know, mu and sigma are the population parameters here, mean and variance, standard deviation. So this is the distribution, as I said, that distribution usually follow population data, and we'll assume that all the population data follows the normal distribution. However, you can ask the question is that if it does not follow normal distribution, then what to do? So there are definitely a remedy. I will discuss at the end of this discussion. If it is not follow the strictly normal distribution, then what to do? Now, so we know that the population follow normal distribution, and for the sake of simplicity in the computation, all these normal distribution curve can be converted into a standard normal distribution curve. This is again in terms of only the parameter variance, and then the mean, somehow it is actually transferred the data in such a way that mean will be considered as 0. Actually, mean is not 0, but the curve is shifted from one position to another position so that mean is now located at 0 line. And with this concept that is called the Z transformation, we can easily convert the normal distribution to standard normal distribution. The expression for the standard normal distribution, which is look like this, it is again Gaussian form and shown in here. As you see, it is only in terms of parameter variance or standard deviation. And it is actually the variables or the random variable, it is Z. So this is the standard normal distribution. And the interesting point here, as you see, so from all these distribution, we shall be able to find the probability at a particular instant or random variable. Okay, so from the normal distribution, it is actually in terms of x. So the probability distribution that we can have, or probability of a random variable p x equals to x can be obtained from the normal distribution curve. Similarly, the probability also can be obtained from the standard normal distribution in terms of the standard normal variable z, that is p z equals to z. And you know the two probability, whether you can calculate it from the normal distribution or it is from the standard normal distribution, they are same. That means p x equals to x is same as p z equals to z. They are same. So they are same so far our functionality is concerned. Only they are different so far their what is called the parameters is concerned. Their look is even same. Okay, so this is the concept that we have already learned in the previous classes. Now, what is the thing that we have also discussed in previous classes is that given a population, we shall be able to collect samples. Now, if I ask you how many samples that is possible that can be collected from a given population, if you say you consider that population size is finite even, so that depends on obviously the total number of sizes, number of samples that you want to collect, sizes of the sample, and what is the procedure that you want to collect the sample. So many things are there. So even from a given population, the total number of samples which are possible, it is huge. And then again, the question in your analysis activities, that is also very important. But here is also at the same time, you should note that if you, you know that, population data also distributed following either normal distribution or standard normal distribution, assuming that population follow normal distribution. At the same time, the sample statistics, if you plot, they also follow some distribution pattern. And that distribution is again similar to the normal distribution or standard normal distribution. And this concept we have planned already in the form of sampling distribution. So in case of sampling distribution, we usually try to find the distribution of samples means or sample variance, whatever it is there. Okay. Now in this regard, the central limit theorem is very important, which also we have learned. So the central limit theorem says that the mean values of all the samples data follow normal distribution pattern, provided that the population also follows the normal distribution pattern. In addition to that, the sampling distribution characteristics, there is one more that is called the sample variance. So if the distribution so far the population is concerned, if we can express it using the Z transformation, using the formula Z equals to x by r minus mu divided by sigma, then the sampling distribution follows the similar Z transformation, but with the different denominator. As you know, the denominator here again, the variance, but it is the variance of samples. So far the sample distribution is concerned. That is actually sigma by root n. This sigma by root n, that is the sample variance, it is according to the central limit theorem. So the things, those are related to population and then sample are in many ways, they have the similarities in fact. But few points that is different, I hope you are able to point it out. Okay, all those are the things that we have discussed in our in the last classes of this course. Now here let's come to the actual problem that we want to think about it. So here in this picture, you see we have plotted a curve, and this curve actually the distribution pattern. And what is the distribution? Distribution of samples means. So here what are the different means values of the samples, and then this is actually the sample means, or it is actually random variable which actually tell the mean of the sample or whatever it is there. Now here, as you see, say suppose 3 samples selected at random from a given population. Then likely that all the 3 samples that you have collected, they should lie in this region, because this is the region where the maximum probability that all the samples should lie. But you may get some sample here or here or here also. So you will get many samples here and there, and then they can be like there. Now again, you know, our objective is to that have a sample, and from that sample, if we can get the population mean or population statistics. So if we get, fortunately, if we get all these samples, that means those are right, those are located here, like, then they will give you the best result. So you will get the accurate inference regarding the population statistics from the sample statistics. But at the same time, if you are not so much lucky to get this kind of samples, if it is like this or if it is like this, then you will also able to predict the population statistics. But definitely, the accuracy definitely is not the same that of the accuracy that we can obtain from this kind of sample. Now here is the question. So question is that, so what should be our what is called the limit, so that we shall consider all those samples which are coming in this area or not coming in this area. That means if we say, so this is my what is called the area so far this curve is concerned. Okay, so this is my area. Now what is the idea is that all the samples which are lying in this region are the valid sample, I should say. But what are the sample that is here in this region or in this region, they should be considered as rejectable. So in this sense, this is a acceptable sample, and whatever this is actually a invalid sample or rejectable sample. Now here its question is that how we can find this boundary, right? So that beyond these boundaries, either right side or left side, whatever the sample value, we will get it. And according to this distribution, they should be rejectable. I mean, our inference will, whatever the inference if we plan, that should be rejected like. So here is a problem, because such a boundary, the infinite possibilities are there. I can think any boundaries, but you should not think any boundary. You have to think a boundary very judiciously. And here is the concept of testing come into the picture. That is called the hypothesis testing. Now let's come to the new term, what is called the hypothesis. And possibly you know the word hypothesis. And if I ask you, do you know what is the Avogadro's number? You can say that it is a capital N. Yes, it is capital N. It is a very famous one number used in chemistry and physics. And what is the value of this number? Because it is a number, it is not a variable, right? It has a value, it's a constant value actually. And this value is 6.023 into 10 to the power 23. Now, I am asking one more question, that, okay, what this number signifies? You possibly know physics and chemistry, then your answer will be very prompt, and then you can tell that. So this is the number of molecules or number of atoms. Now, number of molecules and atoms, what do you mean by that? You can tell that if we consider 1 mole of any material, whether 1 mole of water or 1 mole of oxygen or 1 mole of air, whatever you say, right? If you take 1 mole, then this 1 mole contains exactly 6.023 into 10 to the power 23 number of molecules, or 6.023 into 10 to the power 23 number of atoms in the material. And it is the number that for any 1 mole substance contains the same number, whether it is from iron or gold or oxygen or water. So every 1 mole contains this one. Now that is fine. Now, but the thing is that who told you? Where is the proof? Who proved it? Whether Avogadro, who proposed this number, whether he counted once, taking the gold, 1 mole gold, and then he found, and then he established that, okay, this is the number. Similarly, he collected 1 mole water and then found and got it. So actually, he didn't do that kind of things. There is no laboratory experiment to count, because it is beyond the capability of human to count molecules from 1 mole or even half mole or 10 moles. It's not possible. So how it is? Then he proposed a hypothesis. And this is a hypothesis is very famous and known as Avogadro's hypothesis. So the Avogadro hypothesis says that the volume of a gas is directly proportional to the number of molecules of the gas. And also, according to this hypothesis, there is an extension is that volume of a gas at standard temperature and pressure is exactly is equals to 22.4 liter. And this 22.4 liter gas exactly contains the Avogadro numbers of molecules, that is 6.023 into 10 to the 23. Now there are so many what is called the proposition, rather we can say the theorem, whatever it is, we get it. But all those things, available, in the form of a hypothesis. And Avogadro proposed this hypothesis, and this hypothesis found is very effective to explain many other phenomena in the field of physics and chemistry. And they are now proved things. Nobody can disprove it, refute it, and it is acceptable to all of us. So possibly you are able to understand about that hypothesis. So it is hypo plus thesis. You know what is exactly thesis? What we do in the so far thesis work is concerned. In thesis work, we do some research. We collect some data, do some experiment, and observe some conclusion. And then, okay, we can report results. So hypothesis is also like this. It is also a matter of investigation. It is also a matter of investigation from a data. And then it is also a matter of, based on the investigation, we have to report a result. But it is actually hypothesis means we will propose it, and then we want to prove it that, okay, this hypothesis is correct or not correct. So this is the concept. Now let's come to the more dictionary meaning of the word hypothesis. There are many dictionary from Oxford dictionary. You can get it from the Wikipedia meaning also. Wikipedia is a very popular one. Right, data text repository where many information is available and very popular. And study.com is a very popular one website for statistical learning. And Walpole is a famous book on the field of statistical methods. So I have collected few definitions from here and there. So according to study.com, a hypothesis is an educated prediction that can be tested. Now here you just note down the two things, educated prediction, and it is need to be tested. That can be tested and testable. So this is a prediction actually. Now let's come to the dictionary meaning according to Wikipedia. It is still that proposed explanation for a phenomenon. It is just like 1 mole of gas contains 6.023 into 10 to the power 23. It is just like a phenomenon. And there is a explanation to explain this phenomenon. It is like this. Now, according to the Oxford Dictionary, which is a famous dictionary, possibly you use it, a hypothesis used to define the relationship between two variables. Now you see the relationship between two variables. Here also you see V and N are the two variables. And this actually says the relation. The relation says that is directly proportional. So this is the two variables here. One is the dependent, another is the independent, and the relation between the dependent and independent variable. And there is a different relation. Is a linear relation, is a non-linear relation, relation may be inverse, relation may be simple. It is like this. So here, according to Oxford Dictionary, hypothesis is used to define. That is very important. So it is used to define relationship. Now you see, this is actually the concept that we cannot experiment it by, do some laboratory or whatever it is there, but we can define it, and then this definition gives a very standard relation between two variables. So this is the Oxford Dictionary meaning. And now finally from the Walpole, which is the more statistical meaning, a supposition or a proposed explanation made on the basis of limited evidence. Now this is very important, limited evidence as a starting point for further investigation. Now what is the meaning of limited evidence? That means if you have to claim something, but your claim is based on not the entire data in the world, but only a very small part of the world data, then that is called the limited evidence. Now use this limited evidence and then you propose an explanation, right? That can be used to explain many, right, investigation, or it can prove that many investigation, whether it is correct or wrong. So there are several meanings as you see, but all these meaning apparently looks different, but they are actually giving the same thing. So hypothesis means a proposition. I propose, and then now you can accept it or you can reject it. So all those meaning, actually it is like this. So it is just matter of accepting or it is a matter of rejecting. Now here again, how to do that? That means we have to test a hypothesis. So test a hypothesis means I can propose something and then you test it that, okay, my proposal is acceptable to you or rejectable to you. So here, as you see, hypothesize that one or more parameter. I told you that, okay, it is a relationship between two variables. It is like this. So in the concept of statistical methods or statistical learning, the variables are the statistical parameters. Those are population parameters, sample parameters, is like that. So one or more parameters has some specific values or relationship. That means it is a relationship between some parameters. And here we have to make our decision about the parameter based on some limited evidence. So here limited evidence is exactly same as the sample. So sample here only the limited evidence based on which you have to test a hypothesis. That means whether relationship is valid or not valid. So accuracy of the decision is here. It is expressed, okay, you know, accuracy of the decision usually in the form of test of hypothesis, maybe you can say true or false. But here, the accuracy of the decision is expressed in terms of probability. That means your test will be judged with how much correct, whether it is a 5% probability that test is true or 95% is false or either it fails to accept or these kind of things are there. So here, the accuracy is in terms of probability. That means the accuracy means the hypothesis that I have proposed, whether it is valid or not valid. It is acceptable or not rejectable. If it is acceptable, then acceptable within a given probability. If it is not acceptable, rejectable, then also the rejectable with a certain probability. Now you can understand that is why the probability come into the picture very immense way so far the statistical learning is concerned. Now let's come to the scenario that I have told you, as you have that it is related to courtroom scenario. So here definitely let's see what is the correlation. Correlation between the different entities, those are there so far a courtroom is concerned and so far our statistical learning or hypothesis testing procedure is concerned. Now in hypothesis testing procedure, null hypothesis is very much similar to the defense counsel. So defense counsel will propose something that, okay, my client is not guilty, right? Then here the alternate hypothesis is similar to the pleader who will plead that, okay, no, that, okay, the accused person is guilty. Now here again, the accused person is actually the sample. That means, okay, sample needs to be tested and then it needs to be tested against null hypothesis as well as alternate hypothesis. Then the judge, it is the judge actually, it is similar to the statistical inference who is having learning expertise and then he will take the judgment from both null hypothesis as well as alternative hypothesis and then he will accept either null hypothesis or alternate hypothesis. But he should not accept the two things together or he should not reject both the things together. He either has to accept null hypothesis or reject the alternative hypothesis and vice versa. Now here you can understand that null hypothesis and then alternative hypothesis are the two terminologies that is come into the picture. Sample is already you are familiar to. And then statistical inference, actually we are learning, we are defining it is. Now let's come to the discussion of what do you mean by the null hypothesis and what do you mean by the alternative hypothesis, how they can be. Now I can explain this with an example. So suppose you have given two boxes. The two boxes looks very similar. They are identical appearing, but the content, they contain the different number of balls. For example, box 1 contains 60 red colored ball and 40 blue colored balls. And then box 2 contains 40 red colored balls and 60 blue colored balls. So far the items are concerned in the two boxes. They are different, but the appearance of the two boxes are same. Now that's okay, very simple thing. Now from there many probability question can be posed, and then it can be asked very simple probability that if you pick a ball from box 1, and what is the probability that it is a red ball? It is a quick answer that can be given. Any of you, I think 100% answer will be correct here, because it is simple probability to calculate it. But the problem is a bit difficult if we have considered in different way. Say suppose two boxes are identical, I told you. Suppose one box is placed on the table, but you don't know which box it is. You have not told that it is box 1 or box 2, right? And then it is the task, right, given to you that you have to guess which box it is, box 1 or box 2. As it is only two boxes, so you're guessing, if it is random guessing, maybe with 50% accuracy. Now you can understand that, okay, if you say box 1 is on the table, then what is the probability that your guess is correct or your prediction is correct? You can say it is 0.5 probability. Similarly, box 2, it is 0.5 probability. So you can guess with some probability of prediction. But the thing is that we have to guess it as accurate as possible. That means it should not be with a 0.5 probability of accuracy. Rather, we can say it is 0.01 probability of accuracy, or maybe 0.05 probability of accuracy, whatever it is here. Now, in this context, I can little bit explain so far our hypothesis point of view. Hypothesis is that box is on the table. That means you claim that box 2 is on the table. Now here the question is that how to test the hypothesis. That means how to test that box 2 is on the table is correct, and it is correct with sufficient accuracy or sufficient probability. So here the question comes into the picture there, how to test the hypothesis. Now testing this hypothesis then can be done if we collect sample from it. Now let's see what is the sample that we can collect it. Now I can tell about the sample. It is that so to test the hypothesis, we collect a sample of say 5 balls. I'm telling 5 balls because you have to do some experiment here. Right? So 5 balls is an experiment. You can take 10 balls also, because there are 100 balls. So even you can take 500 balls also, no problem. But in that case, what the thing is that you select a ball and then return the ball to the box, and then you can select the next ball. It is like this, so that you know possibly which you have considered the different distribution that you followed, right? Anyway, so we have to collect a sample of 5 balls, and whenever you collect a sample of 5 balls, count how many number of red balls are there in your sample data. It can be 0 red balls. Your sample may contains the value 1, 2, 3, 4, even 5. And if I ask you to what is the probability that in your sample the 5 balls will be, and then 5 balls is also red balls, probably that problem also very easy to solve you, because you have already learned many probability distribution to solve this kind of problem. Anyway, so what is our objective is that to test the hypothesis, we use such a sample, and that sample can be used for testing the hypothesis that box 2 is on the table. And now you know that how many such sample is possible. That also possibly you will be able to give the answer, because there are 100 balls and then 5 balls at a time, and then how many total samples that we can have. It is very huge number of samples that we can calculate, and little bit a combinatorics problem that you can apply to get the idea of this answer. Anyway, so I'll consider only one sample, and then based on this sample analysis, I have to test the hypothesis that box 2 is on the table is true or not. Now let's see in this context, what is the null hypothesis concept and what is the alternative hypothesis concept. Now box 2 is on the table. If this is the hypothesis, then its null hypothesis says, so it is actually null hypothesis is that box 2 is on the table. That's all. Okay. So null hypothesis is the box 2 is on the table. Now this can be a little bit expressed in terms of mathematical language. I can say that H0 is P equals to 0.4. If box 2 is on the table and if you select a sample and count the red ball, the probability that number of red balls that can be in your sample will be 0.4. So here P stands for probability and 0.4 stands for the probability that the red ball is there in the sample. So it is the concept, it is like this, right? So here you understand that okay, null hypothesis box 2 is on the table, same, but it in a mathematical form, in the form of, right, is a probabilistic language that P equals to 0.4. And this null hypothesis in the statistical learning, right, it is denoted especially with this symbol H suffix 0. So H0. So H0 stands for null hypothesis. Now what is the alternate hypothesis is just opposite to the null hypothesis. If box 2 is not on the table, then it is the alternate hypothesis. So box 1 is on the table. So that is the alternate hypothesis. Now again, expressing this in terms of mathematical language, we can say P equals to 0.6. This is because if box 1 is on the table and if you count number of red balls, the probability that it will be 0.6. So these are the two hypotheses. I hope you are able to understand the concept, the two hypotheses. The null hypothesis that whatever the thing proposed that box 2 is on the table and expressed in a different form, either in a simple English-like form or in a mathematics form, that does not matter. And then alternate hypothesis just others, right? And that is the hypothesis concept. And this is the hypothesis concept statistical learning is concerned, and they are called statistical hypothesis. Now, after learning the concept of statistical hypothesis, then we will be able to do the experiment so far testing the hypothesis is concerned. You need to mute your microphone. Some of you have unmuted a microphone and that is making noise. I request all of you to please mute your microphone. Okay, let's start. Now, so this kind of hypothesis, I mean testing the hypothesis, whether you agree with the hypothesis or you disagree with the hypothesis, that is the matter, and it has many applications. For example, so far the data analysis of the different people involved in your company is concerned. So if you want to determine whether the salary of men and women are equal, so that also you can cast this problem into the statistical learning problem. Rather, we can say that we can solve this problem. I mean, deciding whether the salaries, right, obtained by men and women are equal, and that also can be done using hypothesis testing. Now, and as another example, suppose a product has been launched, and you have to test that whether the product is of standard quality or not. So that testing methods also can be judged using the test of the hypothesis testing procedure. Another example is a very quite popular example which the medicine producer usually follow, that whether a particular medicine, when it is invented, for example, say COVID-19 vaccine, Covaxin or Covishield, whether it is effective to cure a disease. Now, how we can check that, okay, whether it is effectively cure or it is failed to cure, and that also can be done by means of this hypothesis testing procedure, whether it is hypothesis, it is also by means of statistical learning concept if we know it. Now here the main objective of this hypothesis testing is to choose between two hypotheses, null hypothesis and alternate hypothesis. The two hypotheses are in fact contradict to each other. That is why they should be exclusive. That means at the same time, the two hypotheses cannot be together true or false. Rather, it should be either one is true, then definitely other should be false, and that is why. So that is why the name is alternate, or the hypothesis is like this. And another thing is that exhaustive. So the data that you have to have it. So if we accept the null hypothesis, then it is applicable. If you accept the alternate hypothesis, then it is also applicable. And then in that sense, it is the exhaustive. Now, regarding this property of the two hypotheses, exclusiveness and exhaustiveness, we will elaborate with an example whenever we will consider few more illustrations there. Now, let us consider a very simple example. And I'm telling you that, so in your test of hypothesis procedure, you have to decide H0 and H1. That means null hypothesis and alternate hypothesis very cleverly and very clearly. And that is why it is there. Now, our next 2-3 slides, I'll tell you how the two hypotheses can be tested given a problem. That means problem is to test a hypothesis. And then also the properties that they satisfy. That means exhaustiveness and exclusiveness property. Here is a very simple example. And you know the Ministry of Human Resource Development, earlier MHRD, now it is Ministry of Education, it is like that. It's a government of India, right, on entity, which takes an initiative to improve the country's human resources. And they have set up 23 IITs in the country. Now it is also the government's interest to check that whether these 23 IITs, I mean investment of fund to so many IITs is a fruitful or not. To check it, they conduct one aptitude test. It is called the graduate aptitude test in engineering. So engineering aptitude of graduates. Usually this examination is very popular. It is called the GATE examination. So MHRD conducts a GATE examination every year for 1,000 marks. That's fine. Now a sample of 300 students who appeared in a GATE examination in a particular year, say 2021, are collected, and the mean is observed as 220. So that's fine. So that means, so this means shows the standard of the graduates. Now here we have to check whether this mean that we have obtained from a sample of 300 students truly reflects the mean of all the entire students in the country. That means that whether 220, the mean of a sample is exactly, it is the mean of the population. So that needs to be tested. So in this concept, the statistical hypothesis testing, which is used to determine the mean mark of all the GATE 2021 examination. Yeah, so this is the problem. The problem is that we have to check that whether this mean that we have obtained is true mean or it is not true mean. So in this context, the two hypotheses we can define, which is shown here. Here H0 says that population mean is 220. Now that is the hypothesis that I said, that population mean is 220. Now again H1, the alternate hypothesis, that is the, again we say that population mean is less than 220. Now again you can tell about That okay? Anyway, so these are the two hypotheses, null hypothesis and alternate hypothesis, that we can define. So far this testing is concerned. Our test of hypothesis is that population mean is 220. So in order to test this, I proposed here two hypotheses, null hypothesis H0 and alternate hypothesis H1. And this is expressed mathematically in terms of population mean mu equals to 220, and H1 is mu is less than 220. Now, so this is the thing that I proposed. Definitely you may accept or you may not accept. I mean, how I said so that this is null hypothesis, because there are many ways the two hypotheses can be explained or can be expressed. Now here are few other alternative way the hypothesis can be expressed. If I say that H0, which is mu less than equals to 220, or if I say H0 mu is greater than 220, that is also my hypothesis. That means I am proposing that population mean is less than or equals to 220. Population mean is greater than or equals to 20. So all these are valid, but there are certain standard procedure to be adopted, and it is the standard procedure so far the statistical inference mechanism is concerned that null hypothesis should be expressed with an equal sign. This means H0 mean equals to 220. This is the valid composition so far null hypothesis is concerned. If you say so why, I can explain it, but anyway you will be able to understand why I am doing so of your own actually. Anyway, so further the null hypothesis, if it is like this, that according to the standard protocol that it should be the equal sign, then alternate hypothesis also many options that is given to you. For example, in this context of exam, so H1 that we have considered here, mu is less than 220. Alternatively, I could select that mu is greater than 220. That means H0 mu equals to 20 and H1 mu is greater than 220 instead of H1 mu less than 220. That is also valid, right? Also, you can think about H1 mu is not equals to 220. This is. Now, if you note down, I told you that the two hypotheses should be chosen, should be expressed in such a way that they satisfy exclusive property and exhaustive property. Now, definitely, if we consider H0 that is mu equals to 220 and H1 that is mu less than 220, they satisfy exclusive and exhaustive properties. Because if one is true, then definitely other has to be false and vice versa. So this way, they are the exclusive property. And exhaustive property means, here you see, I'm telling you, mu equals to 220 and mu less than 220. If any one is true, then this means that, say suppose, mu less than 220, it is not true. Then definitely mu equals to 220. Then also alternatively, we can say that mu is greater than or equals to 220. And if you see, so mu less than 220, if it is false, then mu greater than or equals to 220, if it is true, then they also satisfy the exhaustiveness property. So this way, the two hypotheses that we have chosen, they satisfy the exhaustive and exclusive property. It is there. Now again, two different form of hypothesis that can be possible. As I said that the null hypothesis always is equal, and then alternate hypothesis may be less than or greater than symbol. Also alternatively, the null hypothesis also can be with not equal symbol. If it is less than or equals, less than or greater than symbol, that is there in case of expressing alternate hypothesis, then such a hypothesis testing is called one-tail test. On the other hand, if null hypothesis is with equal sign, but alternate hypothesis is not equal sign, then it will be, it is called, this kind of test of hypothesis is called two-tail test. So here, the two definitions that you have to remember. Now also you can easily explain yourself that if the one-tail test H0 mu equals 100 and H1 mu is greater than 100 is equivalent to H0 mu less than equals to 100 and mu is greater than 100. They are actually equivalent so far the understanding of the two hypothesis meaning is concerned. Anyway, so this is the concept that you have. And if I ask you what about the two-state test, whether any other alternative it is available, so H0 mu equals to 100 and H1 mu is not equals to 100. Yeah, alternative hypothesis means so far the alternative thing is concerned is not equals means it may be less than, it may be greater than. Now say suppose if mu equals to 100, it is appear that it is not true. Then what is the true is that mu not equals to 100. If mu not equals to 100 is true, then what it does mean that mu is greater than 100 or mu is less than 100. Do you have any perfect explanation to say that it is this or that? If it is mu is not equals to 100 is true. So definitely we cannot convincingly tell about whether mu less than 100 or mu greater than 100, given that mu not equals to 100 is true. So there again further testing it is required. So that test actually you see it is not that only single test is enough, but series of tests that needs to be to prove some other things, getting some other proposition. So those concepts are actually trial and error method and repeated testing so far statistical testing is concerned. Now, so we have learned about very basic things so far statistical learning is concerned, and more precisely hypothesis testing is concerned. And so far we have learned in the field of statistical learning what we mean hypothesis testing and what we mean for hypothesis the keyword is concerned. So we have learned about the hypothesis keyword, and then after that we have learned about the two hypotheses, two different form of hypothesis, that is called the null hypothesis and another is called the alternate hypothesis. Now let's see how the testing procedure in order to test a hypothesis, whether it is acceptable or rejectable. That means whether you agree with the hypothesis, a given hypothesis, or you disagree with the given hypothesis like this one. So it is a procedure. As I already told you in statistical learning, the procedure is like this. Whether this is the sample and based on the sample, we will select, we will agree with the hypothesis or not. So again, this is another sample. Whether this sample, if you select it from the as your data, then whether this sample will help you to accept the hypothesis or not to accept the hypothesis. If this is the another, then you can understand that okay, whether based on the statistics of this sample, whether a particular hypothesis is to be accepted or it is failed to accept. So it is the idea, right? So here, as you know, this is the distribution of samples mean, and all samples are a possibility. So you can say this one and this one and this one. So definitely, this is just simply from the layman's point of view, these samples you will be little bit feel it difficult to accept the hypothesis based on this sample data. And this sample data you will be moderately comfortable. But if this is the sample, then you are highly comfortable to accept or reject a hypothesis. Now here again problem is that so these kind of things it is at random, these kind of things are there. If it is here and if it is there, then you just have to take a judiciously that whether how much this sample data if you consider, if you taken into account in your experiment, whether how much accurate based on this sample data to accept a hypothesis or fail to accept a hypothesis is there. That means what is the probability of acceptance or probability of rejectance based on the testing a hypothesis, and that is based on this sample data. So this is actually the objective or the problem it is with us, and here is the procedure, and it is the procedure is 5-step procedure. Now there are 5 steps to test a hypothesis. The first step, this is very simple. First, you have to, for a given problem, you have to decide H0 and H1, that is null and alternate hypothesis. Once you decide this null and alternate hypothesis, then your next thing which is required to decide the significance level of hypothesis. That means how confidently you want to perform your test. So significance level is also in many statistical books, it is called the confidence level of a test. So if you are 95% confidence, if you are 75% confidence, if you are 50% confidence, these are the different level of confidence. So that means if you want to test a hypothesis, then what should be the significance level of test or confidence level of test? And this significance level or confidence level actually to reduce the error in testing. That means you test a hypothesis which appear as a true to you, but actually it is false. Then that is definitely an error. Similarly, if you reject a hypothesis, but actually the hypothesis is valid, then that is also an error. So this significance level, or that will be okay, it will be decided by a region, and that is called the rejection region. I probably you able to follow what is the concept of rejection region. I told you if you have a boundary and beyond this boundary, left side or right side, if some sample data is collected, then I can say that okay, as this sample comes to the rejection region, I reject it. But whether this boundary, that means the rejection region you decide. So what is the confidence level to decide this rejection region? If the rejection region is very large, that means you will most of the time reject the hypothesis, whatever it is there. On the other hand, if the middle portion is high, then most of the times you will accept the hypothesis. There, so in both cases, whether there or that side, the error is there. So obviously our objective is to minimize the error, and to minimize the error, we have to define clearly what is the significance level of hypothesis test and then rejection region. Then the next test is we have to do the testing using some statistical method. As you know, there are different sampling distribution we have discussed in the last few classes, like T distribution, Z distribution, chi-square distribution, and F distribution. Then here, which distribution you want to apply so far your testing procedure is concerned, that needs to be decided. So these are second step. And then third step is that you have to collect sample data and then calculate the test statistics, means statistical parameters. So far the sample data is concerned, maybe sample mean, sample variance, or sample standard deviation, all those things are there. So it is a sample collection, and then from the collected sample, get the sample statistics. And based on this, step 2 and 3, you have to make a decision whether the hypothesis needs to be rejected or you fail to reject it. And then interpret the result in common language so that any layman can understand outcome of this procedure. Anyway, so this is the procedure. I think in the next class, we can start from the slide number 32 again, starting with the hypothesis testing procedure, and we'll detailize, we'll discuss, we'll explain all the concept in details so that you can understand about it. So let us stop it here today. And if you have any question please, then let me know if you have any question.
Sir,